Is the planet spinning out of sync? Have we unwittingly stumbled upon the secrets of time travel? Or are we at risk of being thrown off the planet? Well, that's what we'll be taking a look at today as we dig below the surface and expose all there is to know about our planet's insides. What role does the core play? And how do recent discoveries affect our life on Earth? Let's find out. As you probably remember from science class, the sphere that we call Earth is a rock planet made up of several layers. These main layers are the crust, the mantle, the outer core, and the inner core. The crust forms the uppermost rock layer that forms the land and sea bottoms. Below it is the mantle, the thickest layer, which is made of semi-molten iron, magnesium, and silicon. The outer core is a liquid layer of iron and nickel, responsible for our planet's polarity. The inner core is a solid layer of iron and nickel that is almost as hot as the sun. Because of its depth and harsh conditions, the inner core is the least studied layer of our planet. In fact, the deepest humans have ever gone is just under 8 miles with drills. The crust alone is anywhere between 18 and 45 miles thick at any point. Never mind the one 900-mile thick mantle, one 430-mile thick outer core, and moon-sized inner core. However, despite our limited physical access, scientists have studied geological patterns for a decade to come up with a clearer picture of how these layers function. For starters, some of the Earth's inner layers rotate at different speeds to the crust on which we dwell. Specific causes for these differing rotations are not known, but scientists believe it is due to their differing components, textures, densities, and state. For example, the inner core, which is a solid surrounded by a liquid outer core, spins faster than the mantle, a semi-liquid contained within a solid crust. For the past 40 years, we've monitored the dynamics between these layers as well as how they affect geological phenomena like earthquakes or tsunamis. The last 14 years in particular have revealed a strange development. The inner core is slowing down and is now rotating slower than the mantle, the outer core, and the crust. And this change could have some interesting repercussions. Of course, with current technology, we have no way of knowing if this slowing down is normal or what normal speed for the inner core is. But we do have a somewhat unorthodox way of seeing that it has slowed down. Between 1991 and 2023, researchers studied and analyzed over 100 earthquakes and tremors along a tectonic plate boundary at South Atlantic's South Sandwich Islands. Seismographs from various nuclear bomb tests were also included to supplement the research efforts. From these studies, geologists could infer the position of the Earth's core relative to the mantle. Since 2010, the seismic data shows that the core takes far longer than usual to reach certain distances. Dividing the decreased distance by the increased time gives us slowed speeds. The research team, headed by the University of Southern California's Professor John Vidal and the Chinese Academy of Sciences Wei Wang, published the study and its findings in Nature on the 12th of June. The slowing down of the inner core relative to the surface of the planet is known as backtracking. Contrary to some media publications, backtracking does not mean that the planet's core has stopped rotating altogether or is now rotating in the opposite direction. The core only rotates in one direction and has never stopped as far as we know. For a long time, there were hot debates about whether backtracking was real, and doubters long held the upper hand because it was difficult to prove. However, studies in the mid-90s were the first to show that the inner core was spinning faster than the Earth's surface. These studies were then used to argue that if it could spin faster than the other layers, it could spin slower, an argument that only poured fuel on the raging disagreements. This is why Vidal and Wei's research efforts have been a game changer and awoken the scientific community to the potential of the under-researched world beneath our feet. Their study has been championed as the most convincing proof of inner core backtracking. So, if backtracking is real, what are its possible knock-on effects on the planet and its inhabitants? To be fair, most of the effects of backtracking are largely speculative. Remember, we've only kept track of the core's movements for a few decades. For all we know, the core has been backtracking and speeding up at even greater rates for all the millennia humans have walked the Earth. That said, let's dive into the speculation. The main speculated possibility is that the slowing inner core's gravitational pull may drag the planet's outer layers to spin slower too. As you already know, the 24-hour cycles we call days are based on the 24 24-hour revolution of the Earth on its axis. Therefore, a slower revolution means longer days. But just what does longer days mean? More hours at the office? More time to binge your favorite TV shows? Or even better, slower aging? Well, probably not. Yes, a slower core could lead to the planet rotating more slowly, but the change is likely to be insignificant. At most, the delay would be a few thousandths of a second, which is almost impossible to notice. So, no extra episodes before bed, unfortunately. But perhaps that's a good thing. Think about it, even an extra hour each day would throw our timekeeping totally out of whack. Our clocks and calendars would be rendered useless, and the whole world would have to recalibrate scheduling, record keeping, and any other aspect of life that hinges on the current 24-hour day. But what if the core keeps slowing down for centuries, you say? Well, according to the study, there is evidence that suggests that is not likely. In fact, Vidal and Wang's study proposed the possibility that the inner core has backtracking and speed-up cycle. This is based on findings that indicate that the inner core had a similar backtracking period back in the 1960s. At present, the researchers believe this oscillation cycle is about 70 years long, with peak inner core rotation speeds expected every 35 years. Based on the oscillation theory, we can expect the inner core to match the rest of the planet's rotation speeds in the mid-2040s. Again, we can mostly speculate here, mainly because we don't know enough about the nature of the inner core and how it interacts with its surroundings. Luckily, technology is slowly coming to the fore in this regard. Just recently, we have discovered that the inner core is slightly lopsided rather than a perfect sphere. Is that somehow causing the rotation speed oscillations? Perhaps. We've also found that the inner core is much softer than previously thought and that it may be wobbling off the Earth's axis. Both of these things could be influencing backtracking too, as could the presence of an inner core, another hot debate topic. An innermost core would certainly be a twist in the story we've long believed about the Earth's structure. John Vidal has his own beliefs about the cause of inner core backtracking. The seasoned geologist argues that the likeliest cause is either the churning of the liquid outer core that surrounds the inner core, the gravitational pull of the more solid parts of the mantle, or some combination of the two. However, the study of the inner core is still very much in its infancy, as are many of the conclusions stemming from it. We simply need more time and data to have a more solid grip on what's going on.
We can't drill straight down to the Earth's center. It's around 3,000 kilometers through the mantle just to the outer core. But scientists at Peking University in China found that seismic waves from earthquakes showed the Earth's core rotating, but also slowing down, and that it stopped just over 10 years ago and appears to be picking up speed, rotating now in the other direction. So what could that mean for the magnetic forces in and around the Earth?
That brings us to the end of today's video. Thank you again for watching, and we hope you learned a thing or two. If you love our content, make sure to hit the thumbs up and subscribe to the channel. Also, hit the notification bell so you never miss a new upload. Until next time, take care.